That's exciting. Okay, today what we're going to do is we're going to learn about factors. We're going to use factors most of the semester in different ways. Before we actually start using factors, we're just going to talk about what a factor is. Okay, has anybody heard of the term factor before? Yeah? Anybody remember what a factor is? Want to give it a shot?
It's another number to be divisible by?
Yeah, that's like a perfect definition. So a factor is a numbers that divide into another number. So for example, they have here factors, the whole number 6 is exactly divisible by 1, 2, 3, and 6. So we would say 1, 2, 3, and 6 are the factors of 6 because they all divide into 6. That makes sense, right? Oh, I can't see my color thing anymore. Uh-oh. See, that's what I mean. Like the pain that you're all going to have to bear with me here. There we go. Let's see if that works. I want red. Very cool. I won't touch anything. So, for a couple more examples, we'll talk about the number 15. If I ask you, what are the factors of 15? That means what numbers divide into 15? The one that everybody forgets is the easiest one. 1. Yeah, 1 divides into everything, right? So it's always a good starting spot. I'd say the number 1, automatically a factor. And then I usually just count up from there. Okay, so for instance, the next number would be 2. Does 2 divide into 15? It doesn't. I can always check my calculator if I really want to be sure. Then I would move on to 3. Does 3 divide into 15? It does. When you divide 3 into 15, you also get 5, which means 5 is also a factor of 15. Right? They could both divide into it. You could keep counting, so you could be like, okay, does 4 divide into 15? It doesn't. Does 5 divide into 15? It does, and we already have it on the list. Right? So once we've kind of hit that point where we're already counting numbers we know, that's when we can kind of stop guessing and checking. There is one more factor of 15. That's another easy one. 15 itself. Okay, so we would say that 15 has 4 factors. 1, 3, 5, 15. Okay, we'll try another one. So we'll talk about 24. I like to start with 1 and 24. Those are both numbers I know that divide in. The easy ones. And then I work my way up. So 2 would be the next number I check. Does 2 divide into 24? Absolutely it does. That means 2 is a factor of 24. When I divide 24 by 2, I got 12. That means 12 is also a factor of 24. So you can see you can be working from like high numbers and low numbers and work your way down into the middle. The next number after 2 would be 3. Does 3 divide into 24? It does, right? So if you go 24 divided by 3, you'll get 3, and you'll also get 8. You then move on to the next number. So you go 24 divided by 4. It works again. You get 4 and 6. The next number would be 5. 5 doesn't divide into 24. The next number I can check is 6. 6 is already on my list. That means I can stop guessing now, right? I've already worked my way backwards, and I've met in the middle. 24 has 1, 2, 3, 4, 5, 6, 7, 8 factors total. It's a lot of factors. Awesome. I'm going to give you a couple minutes. There's 1, 2, 3, 4, 5 examples here. I want you to write out all the factors of those numbers. Okay, so for instance, the number 3 is 1 and 3. And I want you to write out all the factors for those numbers. We were writing out the factors of these 5 numbers. The factors of 10, I always start with 1, right? That's the easiest one. When I divide by 1, I also get 10. So it kind of gives me my upper and lower limit. And then I work my way up. I can divide by 2. That gives me 5. 3 doesn't work. 4 doesn't work. 5 does work. 5 is already on my list. That means there's 4 factors to 10. 1, 2, 5, and 10. Move on to my next number. The number 1 has one factor. 1. Nice and simple, hey? The number 7 has two factors. 1 and 7. The number 18 has a whole whack of factors. 1, 2. See, this is what I don't like. See, it follows my pen. It's gonna always connect lines like that. I'm not very happy with this process. And then see how well the eraser works. Yeah, that's great. Erase the whole. Sweet. 2. 3 goes into it. 4 does not. 5 does not. 6 goes into it. 7 does not. 8 does not. 9 does. And 18 does. So those should have been all your factors. 1, 2, 3, 6, 9, and 18. Awesome. You guys did some factoring last year, depending on whose class you're in. Maybe you just talked about it. You weren't supposed to, so if you didn't, you're fine. But some of you might have talked about it in grade 9 math or in the 10C prep course. Awesome. The next thing we're going to talk about with numbers is two definitions that you do know, I'm pretty sure. It's called prime and composite numbers. A prime number is a number with only two factors. Okay, so like we were just talking about all those numbers with factors. If something only had two factors, we call it prime. If it had more than two factors, we call it composite. So prime number, exactly two factors. Composite number, more than two factors. There is two special cases, right? The special cases are 1 and 0. The reason number 1 is a special number is that it only has one factor. It's the only number that has one factor. In fact, they don't have a definition for it. So it doesn't fit our definition of prime because prime has exactly two factors. It doesn't fit our composite definition because it has to have more than two factors. Therefore, 1 is just like a special number that's just not anything. The other special number is 0. The reason why 0 is special is we say 0 has no factors. It can technically be divided by anything, right? So if you went 0 divided by 2, that technically would work. But it's really not dividing into something. So it's kind of like a loophole. You also can't divide 0 by itself, which is what also throws it off. So when you talk about prime numbers, we say they're divisible by itself, and 0 divided by 0 doesn't work. It doesn't make any sense. So 0 is our second special case. These two special cases. Like that. Look at that. Just connecting all my lines for me. It's like a hand write, but I'm still using regular writing. So it's going to be hard to read. Right? Those are just our special cases. 1 and 0. All right, we're going to write out a list of prime numbers so that you have that list because we will use prime numbers. It'll be part of this first couple lessons that we do. The lowest prime number is 2. It's also the only even prime number. And so 2 is kind of a unique one because any other even number is divisible by 2, which means it's not prime. All right, so the lowest number, 2. The next prime number would be 3 because it can only be divided into two things, right? 3 has two factors. The next one would be 5 because, again, 5 only has two factors, 1 and itself. And if we keep going, 7 would be the next prime factor. Prime number, because it only has two factors, 1 and 7. Now, some people look at this and they try to now start guessing a trend, right? They're like, well, 3, 5, 7, it's all the odd numbers, which doesn't work because if you go to 9, 9 is divisible by 3, so 9 is not a prime number. You go to your next odd number, and 11 is a prime number. You then go to your next odd number, and 13 is a prime number. So now people again start to be like, oh, okay, so it's going to be 3, 5, 7, maybe skip an odd number, then 11, 13. 15 doesn't work either, right? So the reason I keep saying that is because there is no pattern to prime numbers. And if you think you found a pattern, you didn't find a pattern. Right? It'll be broken at some point. So the next one would be 17. And the only way to really know if something's prime is to test it out. Like take it, divide it by things. If it doesn't work, then you're good. The next one would be 19. 21 can be divided by 7, so that one isn't one. 23 can't be divided by anything, so it would be my next prime number. 25 can be divided by 5. 27 can be divided by 9. 29 can't be divided by anything. And you could keep going. Okay, so prime numbers go forever, just like regular counting numbers. There is like a world's highest prime number. They are used for computer security. I believe it's like the best application of prime numbers. So when they are coding and doing all kinds of security, they take numbers, and the best way to hack into it is to be able to divide numbers into its factors, like computer nerd stuff. Anyways, if you have a prime number, it can't be divided into anything. And then they can't guess that number because they can't break it down into things. So if you can ever figure out like the world's biggest prime number, you actually can make a lot of money. Like that. Unfortunately, we use prime numbers for something called prime factorization, which we will get to. Okay, here we have a big list of things. We're going to define them as prime or composite. Prime meaning it's not divisible by anything. Composite meaning it is divided by something. The number 46. I could divide 46 by 2. Look at that. That's my division symbol. Made a perfect plus. Try this again. Divide by 2. Right? 46 could divide by 2. That means it's a composite number. The number 37. I have to decide if it's prime or composite. The way I would do it is I would take my calculator out and I would go 37 divided by 2. Enter. Gives me a decimal. 37 divided by 3. Gives me a decimal. 37 divided by 4, decimal. 37 divided by 5, decimal. 37 divided by 6, decimal. 37 divided by 7, decimal. But I can stop at that one. Now the reason why I can stop at 7 and I don't have to keep going is because of what my decimal answer is. So when I went 37 divided by 7, 37 divided by, that's so painful. I got 5.2 and so on and so forth. The reason I know this is now a prime number is because I've guessed all the way up to 7 and my answer was smaller than what I divided by. So up until this point, my answer had always been bigger than what I divided by. But now look, 7 is bigger than 5. That means I've run through all my possible options. I don't need to go all the way to 37. And that would take a long time if I did 37 guesses. I only had to do up to 7. And I can for sure say this is prime. Awesome. I can do the same thing with 39. Right? So 39 divided by 2 doesn't work. 39 divided by 3 doesn't work. 39 divided by 3 did work. I went 39 divided by 3. I got 13. That means this is a composite. I want you to try with the 101 and 103 and try to figure out if they're prime or composite. Okay, so if you can use your phone as a calculator if you need to, whatever you need for today, just so you can divide some numbers. For 101 and 103, I took my calculator, I went 101, and I just started dividing by things. And I started at 2. And I worked all my way up until I got to 101 divided by 11. And when I did 101 divided by 11, it still gave me a decimal, but the decimal was smaller than 11. So I stopped guessing and I said that is a prime number because nothing divides into it except for 1. Right? The number 1 always divides into it. For 103, I did the exact same process. I went 103 divided by 2, 103 divided by 3, 103 divided by 4, and I kept going. Did we find 103 could divide by anything? Nope. And again, we stopped at 11. So once I divided by 11, the answer was smaller than 11. So I knew there was no way it was composite. It had to be a prime number. It's a slow process. It's a little tedious, but I mean, it's effective and it always works. So beautiful. Now we can mash our two ideas together. So we have factoring and we have prime numbers. So what we're going to do is we're going to look at numbers and discuss them as their prime factors. A prime factor means it's a prime number that could divide into something. So for instance, the number 6 has a lot of factors. It can be divided by 1, 2, 3, and 6. But it only has 2 prime factors. So if you look at these numbers, 1 is not prime, 2 is prime, 3 is prime, 6 is not prime. So I would say the prime factors of 6 are 2 and 3. Right? Those are the prime numbers that could divide into 6. Let's try it with 12. So state the factors of 12. The factors of 12 would be 1, 2, 3, 4, 6, and 12. Those are all the factors of 12. What are the prime factors of 12? The prime factors of 12 are the prime numbers that could divide into 12. In our case, the only prime numbers would be 2 and 3. Good? All right, now what we're going to do is we're going to talk about writing something as a product of primes. Product of primes. That means you could take a number, like the number 12, and you could rewrite it as multiplication, which some of you guys could do right away, right? You could look at that and you'd be like 12 equals, don't write this down, 12 equals 2 times 6. Right? That's me taking a number and writing it as a product, right? 2 things multiplied together. Now what they want is to write it as a product of prime numbers. That means what I need to do is take 12 and make it equal only prime numbers that could multiply to become 12. The trick is going to be to use these prime factors. I could somehow multiply 2 and 3 together to get 12. The way it would, yeah.
You do like 2 times 3 times 2.
That's exactly what you do. 2 times 3 would give me 6, times 2 again would give me 12. Right? That's taking a number and writing it as a product of primes. I use multiplication and I only use prime numbers. I could write this in a simpler way. The way I would write it in a simpler way would be 2 to the power of 2 times 3. What that means is that I have 2 2's being multiplied. Right? That's what an exponent means. That should hopefully just be a reminder. And then times 3. Awesome. It would be really hard if I was giving you numbers all the time and saying write it as a product of primes. 12 is kind of an easier one, right? Because it's a small number. But you will be able to take really big numbers, like 1,000, and write it as a product of primes. And you're not going to be able to do it off the top of your head like that. That would be way too crazy, right? So what we use is something called prime factorization. Prime factorization is our strategy to write something as a product of primes. Express a whole number as a product of primes. This is called prime factorization. There's 2 methods to doing this. There's a division table and there's a tree diagram. Most people end up preferring the tree diagram. I think it's just because they like the way that it looks and it kind of makes sense to them. Okay, I'll show you both ways. It's your choice which way you want to do. We'll look at a division table. So in both cases, they've asked you to prime factorize the number 48. For a division table, what you do is you make a chart. I like to make a T-chart. And in the top right-hand corner, you put the number you want to prime factorize. 48. The left column is going to be numbers I'm dividing into the right column. I'm only going to use prime numbers. So for instance, what's a prime number that could divide into 48? Yeah, 2, right? 2 is a prime number that divides into 48. So that goes in my left-hand column. When I did 48 divided by 2, I get 24 as my answer. And then I do the same process again. What's a prime number that could divide into 24? 2. And when I divide 24 by 2, I get 12. Then I ask myself the same thing again. What's a number that could divide into 12? That's prime. 2. The answer being 6. What's a prime number that divides into 6? 2. Giving me an answer of 3. What's a prime number that could divide into 3? 3. Giving me an answer of 1. There is no prime number that could divide into 1. I always stop at 1. Okay, that's always my ending point on a division table. This thing right here, the left-hand column, is your product of primes. So in your calculator, if you put 2 times 2 times 2 times 2 times 3, it would equal 48. Okay, so that's how prime factorization is formed. Can help you write something as a product of primes. You take a number, you break it into only prime numbers being multiplied together. A division table is actually nice and easy, and it's like beautifully organized. So if you want to use that method, it's a great way to go. People prefer tree diagrams. I'm not sure why. They just like the picture maybe. The way a tree diagram works is you put the number you want to prime factorize at the top, 48, and you start breaking it off into branches. Now, they don't care what you break it up into. You'll see that their first two numbers were 6 and 8. I prefer to use a little bit more of a strategy than just dividing it into two numbers. Okay, like they just chose two numbers that can multiply to be 48, 6 and 8. I would rather choose two numbers where one of the numbers is prime. So for instance, 48 could be broken up to be 2 and 24. So you take 48, you break it up into two numbers that can multiply to be 48, where one of them is prime. Number 2 is prime. If a number is prime on my tree, I circle. Circle things mean like that branch is done. I don't need to go any further off that tree branch. The number 24 is not prime, so I don't circle it. So I have to break 24 up again. Now I'm breaking 24 up into a prime number and a non-prime number that multiply to be 24. I'm going to go with 2 and 12. I circle the number that's prime. The one that's not prime, I keep breaking down. So 12 would break down to be 2 and 6. 2 is circled because it's prime. 6 is not circled. 6 could then divide into 2 and 3, both of which are prime, so both get a circle. My tree is now done because I have no branches that can be broken down any further. Again, you'll notice you have a bunch of prime numbers circled. Those are your prime factorization numbers. So all the circled branches, 2 times 2 times 2 times 2 times 3, that's your product of primes. Both methods get the same answer, right? 2 to the power 4 divided by 4 times 3, 2 to the power 4 times 3. Your choice on how you want to do it. Awesome. Let's do it with a really big number. We have 2 examples here. We have 2,772. I'm going to do this one with you guys. I'm going to use the tree diagram because that's what people tend to prefer. So I write at the top of my tree 2,772. And I'm going to need my calculator for this. So I try to find a prime number that goes into it. I go 2772 divided by 2, and I get 2 is one side of my branch. 1,386 is the other side of my branch. 2 is prime, so I circled it. I then take my composite number and I divide it by 2, and I get 2 over here, and I get 693 over here. I do 693 divided by 2, it doesn't work. I do 693 divided by 3, and it does work. I get 3 over here, and I get 231 over here. Now, I don't know what 231 is divided by. I haven't known what any of these numbers are divided by. I've just been trying my calculator. I'm just guessing. So 231. I guess a prime number that could divide into it. I say divided by 3, and it worked. 377. I then take 77 and I divide it by 3, doesn't work. I divide by 5, doesn't work. I divide by 7 and I get 7 and 11. Both of which are prime numbers, so both get circled. I'm sorry, that's 11. The numbers circled. 1, 2. I have 2 2s, so 2 to the power of 2. I have 2 3s, so times 3 to the power of 2. I have 1 7, so times 7. I have 1 11, so times 11. That is my product of primes after I prime factorize. We have one more example that we're going to try. We have 33,250. So again, you write that number at the top, 33,250, and you start breaking it down. I'm going to go a little faster, so we finish before the bell. 3,250 divided by 2. You get 16,625. Divide that by 5. And you get 3,325. You divide that by 5 again. 665. You divide that one by 5 again. And you get 133. 133 might be prime. It is not. It divides by 7. And 19. 19 is. These numbers become your prime factorization. So I have 2 times 5 to the power of 3 times 7 times 19. That would be my product of primes. Those things multiplied together would equal 33,250. You'll notice there's an assignment section now after your notes. I rushed. We have 5 minutes left. I thought that was about 9:50, not 9:55. So you'll notice that after every lesson, what we'll do is we'll do an assignment section. That's your homework. All right? It's not going to be collected for marks, but people who do it will get good marks on their tests. People who don't do it probably won't get good marks on their tests. Right? So it's more of like a motivation thing. Like you need to find the motivation to want to do that homework. Okay, so today, I think there's like 6 questions there or something. You can start that for the next 5 minutes.